Hey guys, so in today's video we're going to be going over Anki, flashcards, Scikit-Learn, and possibly Pandas. I do have some other things I'd like to work on today, so I might skip on this study session and I might just head over to the other study session. But in order to not break the habit of creating at least one video a day, I figured I'd just create this quick video and then just see where it takes me. So for those that don't know, Anki is a flashcard software system that allows you to learn information over a spaced period of time, and because of that, in essence, you'd be able to study something on day 1 and then again on day 2 and then day 4 and then day 8, or however many days out it might be spread out. And the goal of for myself is to at least get familiar with data science and data analysis, the libraries, so that way I'm only need to study them once a quarter or maybe even once a year eventually. So yeah, so essentially that's my goal, mostly because I'm also going to be heading over and doing a new programming language, which is what I actually need to start working on right now, so then I can move into startups and MVPs, creating minimum viable products. So I'll just kind of dive right in. So what we have in front of us is we're going to be working again with Scikit-Learn. Yesterday, what I eventually ended up working on is using RandomizedSearchCV to tune hyperparameters for a classification model, and in particular for our random forest classifier. And what I did come across and what essentially I was able to do is we were pretty much able to create our RandomizedSearchCV with our estimator, created a dictionary for our param distribution, iterated through all the data 10 times, and then we did each of those iterations on five different pieces of the data. So I'll try to figure out how to really explain what cross-validation is, but in essence, one cross-validation would be an 80-20 analysis, 80% training, 20% testing, and then the second cross-validation would be a completely different 80% of your 100% data set, and another different 20% of the test data set. Verbose, still don't really know, but I'm sure we'll pick it up eventually. So yeah, so let's just move on to the next flashcard. So a lot of these are likely going to be answers because this is just me kind of reviewing them, but we'll just kind of see what happens when it happens. So with regards to what we have in front of us, it is we're importing our metrics and we're working with a regression model. So theoretically speaking, let's say we bring in the data, we perform the exploratory data analysis. From there, we go through and we fit the model, and then after that, we can score it and then evaluate how our model has performed based on the various metrics. And in our case, what we're working with right now, or like what this flashcard is the question. So this is the answer. On the opposite side of the flashcard, it would be the question. And the question is asking, how would you import R2 score, the mean absolute error, and also mean squared error? And then how would you evaluate, or how would you show the score itself? So just know that these flashcards are really just study sessions for myself as much as it would be for yourself, for you. But in essence, all that we need to do in order to view the R2 score, or the mean absolute error, or the mean squared error, is we need to be able to understand what the Y test is, and we'd also need to know our Y predictions. Now, Y test could also be, it's also labeled as Y true. So just know that Y test and Y true are pretty much the same thing across most notebooks. So if we were to go ahead and show this answer, we would see that the question is asking, for a regression model, how can you import and find the score for R2 score, mean absolute error, and mean squared score? And then in this example, we pretty much are just using the Boston housing data set. So what it does is it takes the Boston housing data set. X will be everything except for our target column. Y will be just our target column. And then we'll go ahead and split into X train, X test, Y train, Y test, and then train test split. So from there, we're going to go ahead and take our test size, which will be 20%, and then 80% will be the training size. And then again, we instantiate a model with model equals random forest regressor. And then from there it goes model.fit, and then we do fit on our training data. So it'd be X train and Y train. And then our prediction would be on the X test. And then, yeah, I was also going to kind of mention that if you're working with a classification model, which is not this regression, but if you did need to find the prediction probability, what you could do is you could do ypred proba equals model.predictions probe, and then from there it would also take an X test. So that's a pretty easy flashcard. Yeah, I'll just kind of keep going. So the next one is this is also another answer, but what would be the question that we would need to figure out to get this answer? So all that we have in front of us is it says model.getParams. So this line or sentence is pretty much giving us what the question would be. So the question in our case would be, how can you find a model's hyperparameters? So if we wanted to find any model's hyperparameters, what we would do is we'd go ahead and instantiate a model with a variable, and then we'd have our model on the what would be instantiated. So this could be random forest classifier, logistic regression, k-nearest neighbors. It could be a linear SVC or just SVC, or maybe even cat boost perhaps. And then from there, so long as it's working with Scikit-Learn, you could go ahead and use .getParams, and then that would show us the parameters that we are working with. And if I'm not mistaken, so I'm connected to this. Let's just make sure that I have the data run. Nope, no such directory. So I'm probably not connected to my directory, so let's connect. 5, 4, 3. Okay, so now that we've gone ahead and connected our to our Colab notebook, the one thing that I want to kind of mention is, let's see if I even still have it. So in essence, the reason that we'd want to be able to identify what our parameters might be is so that way we could tune the hyperparameters in a dictionary, and then from there use RandomizedSearchCV to go ahead and randomly select all of the different values within each of the parameters that we could choose between. So notice here we have a range, so we could go for like a range of items, and it'll start at 2 and then it'll increase by 10 all the way up to 403. Likewise, we could also do a NumPy arrange, or even a NumPy like line space, if I'm not mistaken. So just know it'd be in your best interest to go ahead and just search online for the different for the best parameters for like min simples leaf, and just kind of search online best parameters plus the parameter name. So that's why we would want to at least be able to understand or see what the parameters would be, so that way we could randomly select them, and then we could have a we could automatically tune the model and then find the best parameters. So this would work for both RandomizedSearchCV and GridSearchCV. GridSearchCV though would filter or would experiment with everything within the dictionary, whereas RandomizedSearch chooses just a random selection. So again, this is just a study session for me. So if you think I know a lot, just know that one of the best ways for me to learn is to actually explain it, to kind of go over it, and I find it better for me learning-wise, more so than actually coding it out, because I get frustrated like nothing else if I can't just figure it out and if I don't know how to really explain it. So that would be the question. How can you identify a hyperparameters? How can you identify the hyperparameters of a model? So it's pretty easy as well. What do we have next? So again, this would be another answer. So the question to it would be, how can you instantiate a model? No, it would be, how can you manually adjust a hyperparameters? How can you manually adjust a model's hyperparameters, fit it, and then score it? So if we want to manually adjust a model's hyperparameters, what we would do is we'd type it out. So we would type out random forest classifier and estimators equals 100, so that would be like one variable, and then the second variable would be the same model, but the hyperparameter would just be adjusted to, instead of it being 100, it would be 200. Moving on to our next flashcard, what we have in front of us is, again, another answer, and I think that the rest of these are pretty much just going to be answers, so we're just going to try to figure out what the question would be to them. But in essence, what it's asking is, how would you import RandomizedSearchCV, and then how would you split the data, instantiate the model, and then go ahead and call our RandomizedSearchCV, so that way we could then see the results of that. Now, and then also, in essence, print the best parameters, and then from there you go ahead and score your model on the best parameters. Well, what you would really do is you'd reinstantiate the model. So what I'm thinking about doing is I'm going to go ahead and just actually instantiate our model, and let's go ahead and actually use our data set right here, so then we could just dive into it and just recall the information from memory. So let's add some extra lines of code, and let's just go ahead and see what our dataframe.columns would be. Let's actually check the D types. Oof, it's laggy. Why is it laggy? So we would have our D types, we'd have the name, sex we would want to make sure that we dummied. This is float, int, object, so we drop these ones. So let's go ahead and drop some of these. So let's go ahead and do dataframe.drop. And then from there, let's go ahead and drop a number of columns. So let's go ahead and drop our passenger ID, because we wouldn't really necessarily want a different value. We wouldn't want our model to be, what's the word I'm looking for? We wouldn't want our model to be evaluated on a unique value. And that unique value should pretty much not really influence the model itself. What should influence the model are core characteristics or patterns that can be recognized from row to row to row. So if one person that is female, that is 32, that is in P class 1, that would be a better analysis rather than seeing also her passenger ID. So just in essence, just get rid of unique values. And so that would include our passenger ID, our name column, and then what else? So name, sex, age, our ticket, because we would assume that each individual should have their own ticket. Obviously, we could do our own exploratory data analysis to see if that's true. Maybe families purchased bulk tickets, or maybe they had specific tickets based on P class and based on where they embarked from. But for now, let's just assume that the ticket is assigned to each specific individual. What else? Cabin we can get rid of as well, only because there's a lot of missing values, so we don't know who was associated with what cabin. So there's that, and then let's also just get rid of the boat, the body, mostly because I don't know these, and I believe that a lot of these also have missing values. And then let's go ahead and get rid of the home destination, and let's do access equals 1. and then we'll do in place equals true. And then let's go ahead and make that look better. And then we'll go ahead and do dataframe.isNA, so we could view the null or NaN values that we have left over and also see which columns we have evaluated. So we only have our age column. And then we have fair, and then we have embarked as well. Let's go ahead then. So we have these, what would be the data type? From there, sex would be a string, embarked would also be a string, and then what else would be? So I guess just those two, but then we also still need to worry about our age. So for the sake of age and the sake of time, what I'm going to go ahead and do is we'll just go ahead and fill the age with our mean value, but let's go ahead and see if we can do it by P class. So how do we do that? So we go ahead and fill NA, and then from there our value would go ahead and equal dataframe.age. I'm thinking of like using group by, so if we grouped by the P class and then we took the age of the P class, that would then give us the age associated with each of the P classes. But then we might want to create a for loop for that as well to go ahead and loop through it. So how would I want to do this? What time is it? Okay, for the sake of time, I'm not going to work on that right now. I'm just going to go ahead and just do age, and we're just going to do mean, the mean value. The reason that I would have chosen age is because we could assume that the P class, which is the class, for example, if you're flying on a plane, a person would buy first class, second class, third class, business, or whatever. Generally speaking, and just generally being very, very general, an individual that's usually older typically has a little more money to spend on business class or first class. So we would assume that older individuals would likely buy the first class ticket. And that's what these P classes are. There's first class, second class, and third class. So that's why we would want to break it down by age. Age by the P class, so that way we know that they're associated with a younger average age. So from there, what would we do? So we'd go ahead and do axis would equal our column. No, it would equal our row. And then from there we could do in place equals true. And let's go ahead and see what the null value would be. And before we do that, let's also make sure we're calling our age. So we'd call the dataframe.age.mean, that's fine. And let's go ahead and see what the is, if there's any null values. Perfect, so there's no more null values for our age group. Now let's go ahead and let's go ahead and drop our fair as well. So if we're going to go ahead and do fair dot fair dot, do I have numpy? Let's go ahead and actually view a real quick plot from matplotlib.pyplot import plt, and then from there we could do df.fair dot maybe plot.bar fig size equals maybe 10 by 6. Let's see if that does something. So there's a lot of bars, so let's maybe change this to the hist so we can see the values. So generally speaking, it looks like there's fairly small values here, and it's skewed definitely on the left side, but let's go ahead and just let's drop it. So we'll go ahead and do dataframe.fair.drop NA. Axis will go ahead and equal 0, and place will equal true. And let's just do both, why not? And then we also have embarked, right? Yep. Drop NA, and then axis would equal 0, and place would equal true. Perfect. And then from there, let's go ahead and do dataframe.isNA, and then let's just see the sum. And then let's go ahead and do the length of the data frame as well, so we can view the length. So we still have 850 rows, but we did not drop our NA. So let's see. So although we have in place equals true, let's go ahead and get rid of this. Let's also get rid of this. From there, let's go ahead and see this. And we still, I didn't do anything, wow. So why did it not do anything? So let's go ahead, whoops. Just real quick, let's go ahead and copy this. Let's go ahead and do dataframe.locate so we can locate the data where the value is null. dfembarked.isNA. I think .any, if I'm not mistaken. Right? Wrong? I'm not sure. Let's just run it. So I'm going to go ahead and actually just fill the value, just give it a random value. Right? Does it take an axis? No? Yes? 0, and then in place equals true. From there, we'd go ahead and do our fair.fillNA. Values equals dataframe.fair.mean. And then from there, we could do axis equals 0 as well, and then from there we could do in place equals true. And then let's go ahead and view the if null. So values, I misspelled that. Perfect. Now let's also check the length of the data frame again, so it should be like 850. Perfect. So now that we have our data, what would be the data types? So we can finally move on to creating the model. D types. So we have embarked, and we also have sex. Now sex would have, what would it have? It would have 2 values. It would be female or male. And then embarked would have like 3 values. So it would be S, Q, and R or something like that. So let's go ahead and just fill those. So in order to fill those, let's do .pd.getDummies. From there, what would the data be? Let me think. So if we have our data, we do the data frame. Let's just do the data frame then. Let's just do it. And what else do I have? So we have columns. We could do columns. That would actually be kind of useful. So the columns would be sex and embarked, and barkhead, and bark. Do we need to do in place equals true, or is this like good to go? Let's see what the df.dtypes would be now. Still the same thing. So let's go ahead and do data frame 1 equals blank data frame 1. Boom. We didn't see this last time, did we? I don't remember. Either way though, so if we were going to go ahead and view the data set now, so df1.head, that should show us like what happened. So in essence, if it was a female, then this line would be 1, otherwise if it's male, it would be 1 right here. So pretty much 0. So it did what we wanted, which is good. So pd.getDummies is actually really useful for categorical data. And yeah, it's not bad. So I'll just leave it at that. So why did I want to do this? We wanted to do this because we wanted to actually tune the hyperparameters this time. So after just quickly, more or less, cleaning the data, where are we? So next up is, let's just make a pretty column, and let's go ahead and import the parameters, and then let's go ahead and split the data. So what would I need? So import pandas as PD. Technically we don't need it. I'm just going to do like EDA. So this will be EDA for exploratory data analysis. Exploratory data analysis. Something like that. And then we'll go ahead and import numpy as np. Import seaborn as SNS because it's way better and easier in my opinion. And then pre-processing, which we technically already did, from Scikit-Learn dot pre-processing imports 1. Is this one? No. Yeah? No. Yes. Yes. From Scikit-Learn dot, what was it? Is it transformers? No. What would it be? Column? No. What would it be? I'm blanking. I know we have pipeline. Import pipeline from Scikit-Learn dot, what would the other one be? From impute, import simple imputer, but I really want column transformer. So from Scikit-Learn dot, what would it be? Is it pre-processing as well? It shouldn't be. Import column. Yep, it's not. Okay, so I eventually kind of did some research, so it'd be from Scikit-Learn.compose, import column transformer. And from there, we can go ahead and import our model. So model. From Scikit-Learn.ensemble, import random forest classifier, since we're doing classification. Yeah, that'll be it. I needed to move on to the next topic. Oh, good job. So what from Scikit-Learn. Is it not impute? What would it be? Cannot import name, simple import. Did I call it simple? Wow. Simple imputer. Right? Okay. Now that we have all that, let's trash the rest of these and then we'll just recreate them. So next up would be, so we've done our EDA pretty much. We imported Pandas twice for good luck. And now, what am I doing? I don't know. What do we have? Data frame, .dtypes. They're all, oh great. And no, it would be data frame _1 because that's what we're working with. Correct. So from there, let's go ahead and split our data into X and Y and then X train X test. So split the data. And generally speaking, I'll go ahead and comment this out. What you could do is you could do numpy.random.seed. So that way, so long as we seed the data, all that's really happening is pretty much the model will have the same results on your notebook as well as someone else that runs your model on their notebook. So all seeding does is it pretty much keeps the data the same. So X will go ahead and equal data frame 1.drop, and then that'll go ahead and be our survived column. axis would equal 1, and then from there we'd have y, which would equal data frame 1 dot survived, because our y will be what we're aiming for. And then we'll go ahead and split the data, so x train x test, y train y test. We'll go ahead and equal train test split, and then x, y, test size, we'll go ahead and equal 0.2, 0.2, right? And then from there, we could do random state. Is that it? Is it underscore state? Yeah, underscore state, we'll go ahead and equal 42. And then from there, make it look somewhat decent, I guess. Since we have our x train and x test, what would we want to do? We've already pre-processed the data. We don't really need one-hot encoder pre-processing, nor column transformer, nor pipeline. So all we got to do is just fit the model. So let's instantiate the model. So we'll go ahead and instantiate it with clf.random force classifier, and then from there we can do clf.fit x train y train, and then from there we could do y pred, which would be our prediction. So that would be clf.predict, right? Yeah, predict x test, and then y pred proba would go ahead and equal, or we could do y probe for y probability, and then that would equal clf.predict proba, and then again on the x test. Oh, we didn't import our metrics. No, I didn't import. Okay, so for good luck, let's go ahead and import our metrics. So from Scikit-Learn.metrics, import accuracy score. What was the other one? It would be what did we have? So I remember the regression model, which would be R2 score, mean absolute error, mean squared score. This one we would have accuracy score, F1 score, precision, F1 score, recall. But I was thinking of classification report. I'm not actually going to write these, so if anything, just practicing recall this study session. So recalling how to call these and where to call them from. So we have our accuracy score, our classification report. Would it be ROC curve and AOC whatever score? Yeah, actually it would be. So that was the other two. This would also be this is a flashcard, and I remember it asking, how would you predict your accuracy score, classification report, ROC, AUC score, as well as ROC curve. And then again, for the sake of just studying to memorize this, I believe accuracy score would be y true, which would be y test, and then y pred, and then from there classification reports likewise would be y test and y pred, and then from there the ROC AUC score would also be y test and y pred, I think. And then this one would be the false positive rate, true positive rate, and then thresholds would equal ROC curve, and then that would be y test, y pred, and then for whatever reason we'd go ahead and slice it. So, but I don't know why he sliced it then, so I'll just leave this alone. But this is just for the sake of practice. for being able to recall these. So I'm going to just comment it out and import what we really want. So from Scikit-Learn, got model selection. Oh yeah, and it would also be cross-val score for here. So it'd be cross-val score. No, actually the cross-val score would be model selection. Let's see. So it would be cross-val score. And then also RandomizedSearchCV. And let's do grid search CV as well. And let's run it. And then we'll go ahead and move on to our results. Okay, cool. So no errors. So then model selection, we import a cross-val score, RandomizedSearchCV, grid search CV, as well as our train test split, which is not here. Interesting. So yeah, so we would also be train test split. I think I might have imported it on up here somewhere. Regardless, so the next step would be to find our model's metrics, like our parameters. And then this would be our parameters with clf.getTrue, which is one of the flashcards we went over. Another thing you do is we do clf.getParams.keys, right? Nope. Is it key then? Whoops. Maybe. What would it be? Would it be an underscore? I'm blanking. I can easily just search this. Get param keys. So it'd be get params.keys. Params, and then it'd be dot keys. Right? Okay, cool. So that would just be like, it'd be like our data frame df1.columns. So then we can see all the columns. Oops. Oh well. So then we'd have all the columns. But yeah. So what would be the next step? So we'd want to randomize search CV. Definitely have a typo, but oh well. Randomize, yeah. So it would be random forest, and then we'll just do RSCV for random search CV. We'll go ahead and equal randomized search. No, it would be randomized search CV, and then our estimator would be our CLF, which is pretty much just our instantiated model. From there, the param distribution, that's what we would need. So param distribution would equal randomized search grid, RS grid, and let's go ahead and create that. This is going to be fun editing. Five, four, three. So if we're going to go ahead and create random search, it would be RS grid, and then we'd go ahead and create the dictionary, and then from there we could go ahead and create our model. So we do n estimators, and let's just do range. We'll go ahead and create a range of like 1 to, maybe we'll do like 100 to, let's start at 0. 0 to 1000, and then we'll do in steps of 100. So then there'd be 10. Next would be max depth. I think that would be auto and square root. So SQRT. And then next up would go and be, what would it be? Min samples leaf, is that right? And then from there, let's just pick some random numbers. So let's just do 1, 2, 3, 4. And then again, for the last one, let's go ahead and do, we have our max, we have our min. What else do we have? So we have min samples leaf. Yep. And let's do min samples split. And then from there, we go ahead and do, how about 5, 6, 56, and 7. Sure, why not? And then hopefully that should be it. So we'll use that, and then we'll go ahead and do CV equals to 5, and iter will equal 10, and verbose will equal 2, which is just the, no, so verbose equals 1. So that would be the default. And then let's go ahead and do RSCV, and let's see what error pops up. So how did we screw this up? So param distribution. So I must have misspelled it. So what would it be? It'd be param. Did I misspell that? Yep. So what do we have? Init got an expected keyword argument, but I thought that that would be it. So let's go ahead and call it again. RandomizeSearchCV would be the, so distributions, so there'd be an S. Now let's see, and then what else screwed up? Verbose, so we need an E. And then anything else? Nope. Let's go ahead and do random forest. And then I think it would be best params, like get best per params, maybe? How would we get the best parameters? Params? Oops, cancel. Return best parameters. Randomize, yeah, grid search. That'd be like the same thing almost. So what would it be? It would be get that'd be getting the parameters. What would be the best? Predict proba, the log, the best parameters, estimator, best. Nope. How do we return the best parameters? Is it really that it? So it would be CLF or just best params. Right? Wrong? Am I right? I think I screwed up. Runtime disconnect. Good job. Let's go ahead and reconnect. So do I need to fit it? So from here we have RS, so dang. Okay, good job, Doug. So we need to fit it. X train, Y train. Do I need to score it? Maybe. Dot score. What does it say? So we could do this, then we could print the best parameters. Wow. So then from there we do RSCV dot best, how is it spelled? Best underscore params underscore. Best params underscore, and I feel like I missed one thing. Nope. And then they scored it as well. So let's actually just see what the best parameters might, oh, good job. Why do we have failed wording? So what's the answer? No, go back. So not supported between an instance of a string and an int. So why would that be? Why would that be? Would it be max depth? That's why we chose square root. So what could max depth be? So max depth is generally none. So I'm assuming that that's fine as well. Max depth, random forest. The max depth parameter. Let's go to maybe Scikit-Learn or toward data science. So the number of splits that each decision tree is allowed to. Okay, so I had to pause and come back again, and pretty much what I ended up doing was just a quick little research, and honestly I just pretty much just flipped over to the flashcard over here, and I mimicked, where is it? I mimicked max depth, and then that means that max features was the one that I thought would be auto and square root. So I'll leave this alone. I pretty much ran it as well because I knew it would take a little bit of time. So I called it, after fitting the model for X train and Y train, I then selected the best parameters, and what it ended up being the best parameters was this. So let's go ahead and copy it, and then from there what I'm going to go ahead and do is I'll go ahead and save this as random forest RandomizeSearchCV. That's kind of a bad name. Random forest best param, and I'll just save that as a dictionary. Let's press tab, and then from there let's go ahead and reinstantiate our model. So let's go ahead and do CLF best params equals random. Actually, I don't think I need to do this. I forget. So no, that's RandomizeSearchCV. Random forest classifier and estimator. So we can manually retune it, but if I'm not mistaken, I believe after it's already fit, after it returns like our best parameters, like we can see it, if I'm not mistaken, and then we could just score it. So let's do a test, and let's actually test both. Why not? So if we have a random forest, let's go ahead and just say what our max depth is and our n estimators. So n estimators, so it'd be n, do I need to type that out? N estimators will go ahead and equal 600. And then from there, what would it be? It would be, go away. It would be, let's have these down below so it's just easier to see. And then it would be, the next one would be max depth. We'll go ahead and equal 10. From there, min samples leaf will equal 3. And then min samples split will equal 7. And then from there, what else do we have? I think that's it. So I'll leave that alone, and the rest will be default. And then, so this will be our other model that we'll test and we'll compare and see if they get the same score. So right now what we have is we've got random forest, RandomizedSearchCV. Now we've already fit it. So then what I'm going to do is I'm going to go ahead and score it. Dot score. And then let's just check what the score is. So it'd be X test, Y test. And let's also go ahead and fit and score this one as well. So the best parameters, just to see if they'll be the same. I believe that they should be, but if not, at least we'll know. And if we're going to fit, we want to fit on our train. Y train, Y train, Y train. And then from there, yeah, and then dot score, X test, Y test. Yeah, let's go ahead and copy this, and let's do it in the second one. No, good job. So min samples split, run it again. Score of 84, let's see what the scores of this. 84.7, are they the same? Yep, so they're the same. Okay, so that was fun. That only took a little bit of time, and I'm way over. I'm an hour over what I wanted to do. So I'll go ahead and stop right here. An hour of my time, I mean. The video will probably be like 40 minutes. So yeah, so now we know pretty much when working with Pandas, or just this data in general, when you do run RandomizedSearchCV, we can always see what the best results will be, but they will go ahead and return the what's the word I'm looking for? Like it'll be the same output, the same score for our best parameters if we manually enter it into our random forest right here, as it would just calling the random search CV. So they would, in essence, the best parameters would still equal the random search CV after random search CV is run. So you do not need to go ahead and re-instantiate your model. You can just go ahead and score it. So yeah, so I'm gonna go ahead and let's here. Feel free to click on links, whatever links in the description if you want. I don't have my book around here, but I did create I created a, what's it called? What's that word I'm looking for? Like a notebook. I created a productivity planner. I've created two actually. I was hoping that they'd kind of sell on Amazon when I was working on one of my ideas for running a business, but yeah, I don't know, my gut just kind of told me that like it's good and it's along my core values, but not necessarily like something, there's too much competition is what I was getting at. So maybe I'll go ahead and link it in the description. Yeah, I'll end that here. Feel free to click on any of the links below. Feel free to book some time with me on Snugg. I'm willing to assist with tutoring data science and data analysis, in particular SQL, Pandas, Scikit-Learn. I'm fairly confident as well with TensorFlow and NumPy, but definitely really strong with SQL. I just wouldn't really be able to help out with T-SQL, Oracle, creating tables, but with regards to subqueries, left joins, right joins, just thinking of the data in different ways, working with hierarchical data, which that was a nightmare when I first learned about it, or first even just began working with it. Thanks, PayPal. I'll just kind of leave it at that. So feel free to click on any links below. Feel free to go ahead and look over this notebook. Feel free to create your own flashcards with Anki. And yeah, I'll go ahead and see you guys in the next video.